In this video, I'm going to look at objective 5 and 6 from the Chapter 5 study guide. And number 5 says, be able to predict if a reaction or process is likely to be endothermic or exothermic based on the products. So the reason they use process is because we could have physical processes such as phase changes. So for number 5, if we're talking about a physical process, you could have a solid to a liquid, oops, got a little trouble here, solid to a liquid to a gas, and those all require energy because you're going to speed up and spread out the molecules. So these are all endothermic processes. On the other hand, if you go from a gas to a liquid to a solid, those all need to lose energy or release energy. So those are exothermic processes. So if I saw something like H2O solid to H2O liquid, I would say that that's going to release energy. It's going to gain energy to go from a solid to a liquid and be an endothermic process. The other thing to look for when you're making this prediction is whether or not it's a common type of reaction, or if it's obvious there's bond breaking only or bond making only going on. For example, if I have CO2 gas and it becomes C solid plus O2 gas, I've done some bond breaking in there, and bond breaking, they apparently haven't formed any new bonds, so my bond breaking is going to be an endothermic process. Well, on the other hand, if I had something like O plus O, and it'd probably be a free radical like we saw in the stuff with the ozone, forms O2, that's bond making, and bond making is an exothermic process. The other processes that always are exothermic are combustion and neutralization. Those always release energy. Dissolving, solvation, often. So if it was any of these three, if I could tell it was combining with O2, if it was an acid plus a base to give me water and a salt, or if I had a solid plus water and it became aqueous, those are all ones I would bet on being exothermic. Which answers question objective number 6 here, be able to predict the change in enthalpy for neutralization reaction. It's going to be exothermic, so that is going to be a negative delta H anytime it's exothermic. So not only neutralization, but combustion or heat of salvation, I would expect all those to be a negative enthalpy.